I get it a lot at barbecues when I hear people say, "Oh, robotics." You put people out of work.
Oof.
And I can see that as a very common misconception.
Ouch. Yeah.
It hurts me a lot because I'm not for that at all.
Yeah.
I find it day in, day out. We need more people to keep feeding the robots. There are things that I mentioned robots can only do, but there are so many more things that only humans can do.
Brock Dominish, welcome to the Entrepreneurial Engineer podcast.
Thank you, Darren. Thanks for the invite.
Yeah, it's funny because we were just talking in the lift, and I'm going to ask you the question again. You're at a barbecue and someone comes over and they ask you what you do. What's your answer?
Yeah, well, my answer is obviously a wrong one. My answer is mechatronic engineering, and the response is normally mecha what? What is that? And so then I have to explain it. It's a fusion between electrical, computer, and mechanical engineering. So thinking of all the good bits of mechanical put together with a bit of electronics, think of motors, and then computer software, and then you think about devices like robotics or automation. So that's what I am, a mechatronic engineer, and I specialise in robotics and automation equipment.
Awesome. So I think now you should be saying I'm a robot engineer.
I try that, and normally people just kind of tune off. So I do go sometimes, depending who the audience is, a robot engineer is a safe bet.
Yeah, I'm into robots. I like that.
I do robots, yeah.
Yeah.
That's pretty much it.
But I talk a lot about that moment when you do say what you do, or people do ask the detailed questions, and you do get people who are curious, but then sometimes you're right, those people that their eyes glaze over. How do you combat that? Because I could figure that what you do is very complicated.
Yeah, I think it's the same as any engineering field. It can vary in complication at different levels. But yeah, people's eyes glaze over. I kind of just explain what I've done in the past. So I currently work for a medtech company, an Australian manufacturer, Australian success story. So that kind of spooks some interest, gets the ears pricked up a little bit. And when I mention I work for ResMed, people do recognise that name commonly. So that's good, that helps.
Yeah, on asking you to come on, I saw ResMed. Oh, ResMed. So what's your focus at the moment? What are you working on? What's what's something that you're currently doing that's sort of exciting and we can talk about?
Yeah, there's a lot of ResMed happening. I don't know if people are familiar about ResMed.
Maybe tell us. Give us a bit of background and history,
sure.
And a bit of a take on that.
Sure. So
where your career is going.
ResMed started 35 years ago now in Sydney. Australian success story. Now 140 countries globally, over 10,000 ResMedians around the world. A market capitalisation of about $33 billion US dollars.
Wow.
So it's gone from a very small company to a very large company very quickly. I've been there for 13 years now. And basically we treat sleep disordered breathing diseases.
Yeah.
So some people might have heard of sleep apnea.
Yeah.
Where people actually stop breathing while they sleep. And signs of that, things like snoring or very tired during the day. So ResMed has basically designed, and we service that market by making what we call CPAP devices, continuous positive airway pressure, where people actually sleep with a mask on their face and have a little pump beside their bed. And that generates a small positive airway pressure that actually stints the throat open and stops people, or prevents people from having apneas as they sleep. So people go from, really suffocating multiple times an hour, 30, 40, 50 times an hour, down to almost nothing. So ResMed, making those CPAP devices, are saving lives every night. And there's millions of people around the world with sleep apnea. And we treat only a small portion, so it's a passion of mine is helping people. It's a passion of ResMed's, supporting millions of people around the world to live healthier, happier lives. And what I do at ResMed as being the principal automation engineer is we automate a lot of our manufacturing processes. So starting in Sydney, manufacturing, we continue to manufacture out at Bella Vista, northwest Sydney.
Yeah.
A proud Australian manufacturer of medical devices. And part of that is automation and how we can keep our production lines running around the clock, 24 hours a day, A lot of that is to do with robotics and automation. That's the part I play. And in terms of new things coming out of ResMed, we're always releasing new products. We co-manufacture in Sydney and Singapore, and also a little bit in the USA, and that's going to be growing. But there's always new products coming out. Think of the new iPhone. Every few years there's a new iPhone out, or a new Samsung. ResMed is very similar. So every few years there's a new product.
Yeah.
So we're always working on that. New designs, new development, new technology.
Yeah.
And hopefully launching the production in Australia, and similarly in Singapore and the USA, as those products increase in demand and popularity.
Because a lot of people, and I've heard of sleep apnea, and I didn't actually realise the extent of it, and I think a lot of people probably don't know they have it. And I think in society, a lot of people would see, that's like a doctor's thing, or it's very much a health thing. So to understand that the engineering that must go behind the machine and how it's made, and your role in automation, gives people a real, more of an understanding about, this isn't just something that you go to the doctor and here's just the machine. It's like, someone had to design the machine, build the machine, automate the process to manufacture that machine. And that's the sort of thing that, I think is really important for people to hear about. Because I could only understand that from what your role is, that impact that you have on automating your processes, how much does that really impact, I guess, the end product? It could be made quicker, obviously it might be better made cheaper. What sort of impact does that have? Because you would know maybe some of the nuts and bolts of that.
Yeah, good question. And like you said with the doctor, if anyone does suspect they do have sleep apnea, please go speak to their local physician. Yeah. Or go to resmed.com.au as well.
Yeah, nice. For
good
plug.
Information. But yeah, in terms of what I do and input into product design, so people will sleep, for example, with a mask on their face, and that provides a positive airway pressure. ResMed makes the best masks in the world. Sure, I'm biased, but our PD guys, they could design the world's most smallest comfortable mask in the world, but if we can't make it, then the mask is no good, right?
Sure.
The same thing goes with a bridge or something structural. It could be the best looking building in the world, but if it's not structurally safe, it can't stand on its own feet, then it doesn't exist.
Yeah.
So I think that's a really good thing to keep in mind, particularly with manufacturing, is when you've got so many smart people and so many great ideas and how we all come together. Yeah. Quite often, even before ResMed, manufacturing's always at the end of the cycle. All the PD, all the development, all the studies, all the R&D, and then we have to manufacture it. So it's good to get that closed loop happening and get the end people, manufacturing people up front, and get the designs and the input up front. So there's examples of products out there that have components or features just for automation.
Right.
Just for handling. Think of a Coke bottle, for example.
Yeah.
There's features on the Coke bottle, plastic Coke bottle, that are only there to convey the Coke bottle through the production line.
Yeah, right. Like what?
Under the
bottom section, or the lid, or
underneath the lid, there's a little
ring. Yeah,
there's a little ring. And no one notices it. It feels nice when you drink it. But that ring is suitable for air conveying. So when you go to bottling plants...
Air conveying?
Yeah.
Right, so tell me about... I'm super fascinated.
We're digressing a little bit.
No,
but air conveying, it is. Air conveying is a concept where bottles, plastic bottles in particular, get suspended by that neck, and they're within a chamber. Air through fans is passed down. So bottles are flying through factories at probably 500 bottles a minute up to 1,000 bottles a minute speed. So if you go to a bottling plant, there's air conveyors everywhere just passing bottles around, empty bottles to the filling line. Once they get filled, it's the bottom base that gets conveyed through to the packaging lines and things like that. So that's just one example. And ResMed devices have key components designed just for the automation of those products.
Wow.
And that's really important. Like I said, that continuous loop, have features in there for automation and manufacturing. A design for manufacturing, design for automation. There's some terms that may have been thrown around in the past, but Yeah, it's like anything, I suppose. Structurally, you need to have features in the building.
True. Lifting
for
lugs for precast panels.
Exactly.
There are lots of sort of things that are there for certain reasons for transport.
Yeah.
I don't think I'll look at a Coke bottle again in the same way, right? But just thinking that there are, and the more you think about it, and I think a lot of people just glaze over that stuff.
Yeah.
They would never know the nth degree of why that is the shape of the bottle. They think, it's ergonomic, right? It fits in my hand. But actually, we'll know there's other reasons behind that in the manufacturing process that are there for those reasons.
And that's the beauty about it. No one knows, no one cares.
Yeah, that's right.
But that, and it's not just unique to Coke. I shouldn't drop brand names, but
that's important.
Any bottling plant around the world, and it's a similar thing. That lip is for air conveying.
Yeah.
And that goes from before the bottles are made.
Yeah.
They're in little pre-molds, and they go to a blow molding machine, which blows air, hits the pre-mold, and then blows it into the shape.
Yeah.
That's all conveyed using that lip.
Yeah, wow. So how did you get into robot engineering? Where did you start? What were you doing? And did you ever think, I'm going to be an automation engineer or maybe mechatronics engineer? And did you do it at uni? Give me a little background about the young Brock.
Yeah,
days.
sure. I think like all engineers, we all start off as tinkerers.
Yeah.
Lego was my fallback toy as a kid growing up.
Yeah.
Was renowned for pulling things apart, radios.
Yeah.
My brother's toy cars. Just trying to figure out how things worked.
Yeah.
And that was very young. Growing up, I always thought I wanted to be a sound engineer.
Okay.
That was where I'm a musician, so I was going down that path. But then one day I heard about mechatronics, and I've been in the industry for probably 21 years now. So, 25, 26 years ago, like we said, not many people know what mechatronics is now, let alone back then.
Yes.
But when I heard about it, that's what I want to do. Robotics, I had a real passion. I don't know, maybe not your generation, but remember Beyond 2000?
Oh, I love Beyond 2000.
Stuff
Was it
like
like Tuesday night, 8:30, or maybe Monday night at 8:30?
Something like that.
And I got to stay up late to watch it. Yeah. It was the only time I was allowed to stay up late.
Yeah. So just stuff like seeing, what now is very basic, but the infancy of robotics back then and automation. I think sometimes engineers are born. We're just natural engineers, and I think I'm one of them. I always told my parents I wanted to be a mad scientist.
Oh, yeah.
Which, I think I'm probably a mad engineer now. By combining everything, it's probably the mechanical, the electrical, and computer. It's as mad scientist as I can get, I think. And it's a university degree.
Yeah.
Proud Western Sydney University graduate. I grew up in Western Sydney, still live in the area. And they offered the course. A few universities offer the course now, more so, which is good. And also global. It's a well-known engineering degree that a lot of companies are now looking for, just to get that broad experience and knowledge of people. I'm not sure about your industry, but when you think of mechanical engineers, it's very mechanical and making things mechanically sound. Then you think of electrical engineering, and it's all about the electrons and electricity. Yeah. And then I don't know if you've worked on projects where they come together and they're always clashing.
Yeah.
They bring the software guys on top.
Oh, forget it.
Yeah, I think of IT departments and engineering departments, we just don't get on sometimes. So I think a lot of companies now realise the benefit of mechatronics. I was a natural fit for that, and my career is 21 years. I started, always worked in Australia, but started off in the welding industry. Yeah. Putting welding equipment onto robots.
Oh, yeah.
And servicing, a lot of, tier one car suppliers in the industry at the time. Yeah. We did have a car industry back then.
One time, I think.
Travelled the world, installing robots all over the world.
Cool.
Welding robots, which was an eye-opener. Particularly, the growing economy of China. One of my first projects was installing 10 robots in China.
Wow. Welding robots.
Welding robots, yeah.
Right, so tell me, because I've got so many questions, and one was more a statement that it sounds like you're pitching that you're 3 engineers in one, so that's great. I love that. But tell me about welding robots, because it sounds like you've sort of done that globally.
Yeah, well, for those that know welding, I'm sure you do in structural.
Welding,
join two metals together, two or more. Welding is everywhere.
Yes.
Anything metal. It's highly likely it's welded together. So car industry is big.
Yeah.
Supplies into the car industry.
Space industry.
Huge.
Yeah.
Building. Think of hardcore Australian manufacturing.
Yeah.
Farm goods. Welding. You've probably been to a few factories around, and quite often you'll see welding around. So the ability to, and generally it's done by people, welders.
Yeah.
Very, very talented and qualified tradespeople that do that welding. But places like Australia, it's hard to find welders now. And even all over the world, it's any trade is sometimes hard to get. And welding is a hard, tough trade. It's hot.
Do you think that the days of the boilermaker or the welder, or do you think that's over?
Oh, I hope not.
I don't want to segue too much, but you raised very valid point. Like thinking about that is it a dying trade?
Look, I don't know if I'm qualified to make a call. I definitely hope not. Some of the smartest people, and the most down to earth people I've met are boilermakers.
Yeah, me too.
And that goes for a lot of trades.
Yeah.
And particularly as a fresh engineer, coming out of university, think, I know everything. Turns out we don't.
100%.
And just leveraging off all those years of experience of boilermakers, electricians, plumbers. It's just I hope it's not a dying trade. And
when you've got two big bits of metal you've got to weld together, and you built the robots to do, I can only imagine some pretty crazy welding. Are there some things that a human couldn't do in welding that the machine could, for example, of maybe something that you worked on?
Yeah, absolutely. There's a few cases where people just can't do it, particularly continuously.
Yes.
Like if you're doing one-off, two-offs, that's fine. But when you're doing thousands, it's just not possible and sustainable.
Yeah.
I think of the first job in China that I exported Australian goods to China to manufacture. They couldn't get the skilled labour. It was in rural China.
Yeah.
And they're making gym equipment. Think of the TV infomercial, treadmills, exercise bikes, being churned out by the thousands in China. They've got millions of people, but just getting that quality and the repetitiveness and the reliability of workforce anywhere in the world is really tough. And I think that's where the beauty about automation and robotics come in. When you want a consistent weld or a consistent medical device or a consistent Coke bottle or bottle, that's where really the benefit of robotics and automation comes in, if that makes sense. And look, there's some great success stories in Australia where robotic welding happens daily. I've been out of the industry for good probably 15, 16 years out of the welding industry. But I keep my eye close and my ears close to the ground, and it's like anywhere where you start, you always have a vested interest.
Well, I mean, loving or hate him, I did read the Elon Musk book, and there's a bit in there he talks about at SpaceX, or whoever wrote the book, I can't remember, but anyway, that he actually made some first welding machine that there was no other in the world that could do the weld this big, and that was one of the core reasons why he could do what he did with SpaceX. And that for me that's innovation. That's really the beautiful part of engineering, where you could go, well, everyone's doing it this way, but I'm going to do it that way, and because of that is a core reason why you could build a rocket, for example. I mean, super insightful. And there's so many examples. I think of the medtech industry. There are components now that are so small and so intricate they cannot be made by a human hand. It's impossible. Wow.
You need automation and robotics to deal with them. You need automation and robotics just to get them off the mold. Or to handle the components. Think of clean room environments as well. So there's so many examples.
So tell me how small, like, you see this stuff sometimes where it's like, there's a robot that's the size of a fly, or some mini thing that will, you can put it in you'll swallow it and it can go through your body and clean your arteries or whatever. But what are we talking about, like, in terms of small? Like, is it a millimeter? Like, what is it?
Yeah, well, I have to profess I'm no expert on the micro
I know,
robotics.
But still,
but yeah, in my industry, we're talking sub-millimeter accuracy.
Wow.
On some of our parts, we're talking about microns.
Wow.
Of accuracy. Things like molding tools, and the tolerance are extremely tight.
Mm-hmm.
And these running thousands of shots a week. Millions of shots in their life, so keeping those micro accuracies, and similar things in the press tooling industry, which was big as well in Australia. We're talking about accuracies and tolerances of microns. In terms of robotics and equipment, I don't go in that small micron. I'm more of the industrial big robots. Think of a car line you probably would have seen on Beyond 2000 and other shows over the years. Big industrial robots is what I deal with. And look, you're looking at a 0.1 millimeter repeatability on those robots. So when you've got things, big robots swinging around, some of them, the biggest one I've done can pick up 1,000 kilos. And when you talk about the repeatability of 0.1 millimeters for that robot, it's pretty cool. So you can do some amazing stuff with that technology.
So one of the other reasons I really wanted to talk to you was obviously a lot of people talking about robots, a lot of people talking about, am I going to own a robot? Will I have one in my house? Are construction workers going to be replaced by robots? Driverless vehicles I might park, but talking more about humanoid robots. What's your take on that? Considering that you're, who you are and your take, and that you've worked with so many robots that may not have a humanoid, sort of function, but, I guess I would only assume that you're quite interested in that and might have a bit more of an insight than what I would.
Absolutely, yeah, good question. I thought it might be coming.
Yeah.
I'm very interested in humanoid robots. I think it's exciting. I think it's just a matter of time, really. Like it seems like the curve of progression is just crazy at the moment, and obviously all that's driven by AI, machine learning, advances in that technology. It's one thing to have motors that can do the force or mechanical design. Now it's really functions of software that is making that possible. I think I don't know, put a timeline on it, but I think we'll be looking at 10 to 20 years and we'll have humanoid robots definitely on the production floor and potentially in our house. And if you think, over the years, we already have robots in our house. Think of dishwashers and washing machines.
Yeah.
Mechatronic devices, you've got mechanical and electrical and computer in all our homes now. Think of robot vacuum cleaners, robot lawnmowers.
Yeah.
You mentioned robot cars, but what I foresee happening is not those anymore, but a humanoid robot that can do that for you. Imagine a humanoid robot that can get into any car and drive that. Think of a humanoid robot that can pick up your vacuum cleaner and vacuum upstairs and downstairs and the stairs and clean the car. I think that's going to be the game changer. Right or wrong, I don't know. I don't know what the answers are.
Yeah.
I think in terms of anything, I get it a lot at barbecues when I hear people say, robotics, you put people out of work.
Oof.
And I can see that as a very common misconception.
Yeah.
It hurts me a lot because I'm not for that at all.
Yeah.
But robotics, particularly for my 21 years in the industry, has only enabled people to work.
Yeah.
I find it day in, day out. We need more people to keep feeding the robots. There are things that I mentioned robots can only do, but there are so many more things that only humans can do at this stage.
Yeah.
And I've seen so many manufacturers in Australia continue to manufacture in Australia because of automation and robotics. And I think humanoid robots are just going to be that next leap in that area. And if you think about it, the robots I work with, car lines, that's where they really developed, was the car industry.
Yeah.
And the car industry has done nothing but go from leaps and bounds. Like obviously, economic reasons, I don't know about, and companies fall and companies don't go well. But automation is always there at producing cars. And you still need people to produce those cars and feed the robots and program the robots and service the robots and install the robots. So I think the humanoid robots is just going to be the next evolution of automation. I think it's exciting. I think it's potential for everyone. And I think probably see them in the factories first. Construction zones, I think eventually. You would know more than me, but I'm sure there's...
Yeah, I think they're already on factory floors, if you believe some media.
Yeah.
I asked someone whether or not you would prefer a driverless car or a car being driven by a robot as like a taxi or an Uber. And it's surprising how many people say, I prefer to have the robot.
Really?
Yeah, and you're going, well, hold on. Even if it was a driverless vehicle and you put a robot in it that was driving it, would that make you feel more comfortable? A lot of people are like, yeah, I would feel more comfortable.
Really?
Which is strange because you think the car would have more sensors but then you go, well, is the humanoid robot plugged into the car robot and they're both working together? It just goes on and on.
36% of listeners won't subscribe to this podcast, and that's a real shame. If you want to help me share the stories and help others learn and grow, then please like and subscribe.
That's an interesting question.
What do you think? What do you think?
Look, knowing how sensors work and systems, I don't mind if it's a car or a robot sitting in the chair.
Sure.
But I just think how it opens it up. If you, for example, in 20 years' time, you had a humanoid robot at home.
Yeah.
You've got a very complex and really interesting control system. That's, think of the CPU it must need, or why replicate that for your car and your vacuum cleaner and your robot lawnmower? If it was all in one, why not? Think about phones now. It's all in one. Our calendars, our email, everything's in our phone, right? All in one. I don't carry a diary anymore.
No.
You make a call, it's on your phone. Everything's on one device.
Yeah.
So imagine if all the smarts was on one humanoid robot that could do everything for you. So that's going to reduce the cost of the cars. You don't need high computation in the cars. And you're right, does the humanoid robot plug into the parking sensors and the LiDAR sensors and the indicators and the
GPS
and the GPS.
All the rest, yeah.
Absolutely, it becomes one mechatronic system.
Probably charges itself while it's driving.
Yeah, exactly. So that's a good example of a mechatronic system, right? It's everything working together. You'll find mechatronic engineers everywhere in the car industry, aerospace, manufacturing, construction, product development. So circling back to mechatronics, which is a passion. I think that's a real important thing that for young engineers or young people thinking about engineering, I really implore them to think about mechatronics.
Yeah, well, I was going to ask that to say, I'm at school, love Lego, obviously mechatronics sounds like a great pathway, people who are inquisitive or curious, or maybe, like you said, maybe are born. What would you say to those young students, and how do you believe the industry can entice, more mechatronics engineers?
Yeah, good question. That's a tough one. I think for those that are thinking about engineering, there's so many good resources out on the internet, which I didn't have back in 1998 when I was in high school. I'm not sure about you, but we had old books, university books that you could go through instead of university courses. And I did in Year 12. I visited Western Sydney University and I saw their robot lab.
Yeah.
And that's exactly what I do. I want to do it here. So yeah, I think just explore, have a look at YouTube videos, look up mechatronic engineering, look at what's out there and see the different avenues. And think about what I mentioned this recently at an event which I was speaking to. And back in the day, people would ask, what do you want to do when you grow up? So just rephrase a little bit, and what problems do you want to solve when you grow up? So I've got 2 young daughters, and I started asking them that. So I used to say, what do you want to do when you grow up? And it's obviously a YouTuber and a dancer, and that's all fine.
Yeah,
but then exactly. So obviously they'll make more money than me, so that's good.
Yeah.
But if that doesn't work out, so I've rephrased it. So what do you want to do when you grow up? And that prompts different answers. So I ask anyone out there just to rephrase that question. What do you want to do when you grow up? And it might be working in aerospace. It might be working on buildings. It might be working in a factory. So what do you need to work in those areas? What problems do you want to solve? And then that kind of answers your question. I think, being biased, I think mechatronics can solve a lot of those problems by being able to combine a lot of the engineering skill sets. So yeah, I hope that answers your question.
Yeah, I could only see that there's going to be more need. And even now, there's a massive shortage of engineers. We've got 25,000 engineers in Australia retiring in the next 5 years. There's engineers who don't become engineers, they go do something else. And I could only see that something like mechatronics engineering is something that we need to invest in Australia and maybe globally, but definitely in Australia, so that we have the core talent and resources to be able to drive this industry forward. Because I could only see that with robots and coordination of all these systems and mechanics and electricity that can do more and more and more. And you talked about the power of software and how that's accelerated. Just seeing that become, I could see it becoming the number one engineering degree, only because I think the influence that mechatronics engineering will have on all engineering will just surpass all other engineering.
Wow.
And that's my take.
Yeah.
I'm not saying that people will be redundant. I'm not saying people will lose their jobs. That's not what I'm talking about. I'm just talking about, when you look at the impact of what we're talking about, robots, machines, and software, and how that will change the landscape across, I think, all engineering. And I think that's why I asked the question to how do we get more people now into mechatronics engineering? Because like you said, 10 years time, 20 years time, like we've got 20 years experience. In 20 years time, the people that started today, and whether it's 5 people, 10 people, maybe it's more, they're going to be facing even greater technological change than we are now. And if they're not going into it now, when we get there, we won't have the people that know the mechatronics or whatever it is to be able to take and even make it go even further.
Yeah.
So yeah, it's just a reflection piece on that, and I think that's part of the conversation because I could just see that becoming just so much more important for our future.
Yeah, I think you're right, and I think you raise a very good point. I am encouraged though, school STEM.
Yeah.
Is huge. Both my girls, I go to a local public school and they've all done robotics at school. So I think, that's something that I didn't have an opportunity to do in primary school or high school. So I think, there's this natural nutrition through the schools that is opening people's eyes up to things like mechatronics or engineering. So I'm encouraged by that. Great company like ResMed that I work for, we constantly have school groups coming through, engineering groups, and that's how we influence the new upcoming engineers. We have a great graduate and intern program as well. So yeah, and every day of the week almost we've shown people through our factory to show them, engineering and what we can do in Australia. And I think it's a really important skill set for the country, engineering, because like you mentioned, if we don't have that skill set coming through, then there's things that we just cannot do locally. And that's frightening. And, when the car industry left, probably, starting about 10 years ago now, it was a big sad thing, and not just because the car industry went and all those people that worked. It's that skill set that we once had, the Boilermakers. I think Holden used to employ 50 apprentices a year or thereabouts. And look, there's still apprenticeships and things out there, but it's just that natural, cycle that we once had that I really think we have lost over the years. I think that's a bit frightening for a country.
Yeah, I often talk about how do we retain that knowledge? How do we retain, some of the I don't call them grey hair engineers, getting grey or whatever, but some more experienced and seasoned engineers or boilermakers, welders. How do we retain that knowledge? And I think that's a challenge that maybe all industries face, but I feel like where we are now, maybe you talked about cycles, feeling very much that where we are now in this rapid technological change and everyone, AI and all the other stuff, robots, how do we get, as engineers, I would think leaders, how do we get and retain that knowledge so that it's not lost or it's not forgotten or, we don't take those learnings into our future?
That's a good question. I think you do a big part of it with your podcasts and just getting out there from where I've only met you today, obviously, but obviously we see each other through social media and LinkedIn in particular. I think stuff like that helps.
Yeah.
I was lucky enough to go to an Engineers Australia event recently.
Cool.
And it was a networking event, and just the young engineers coming through, I was blown away.
Yeah.
Like, I know that we're concerned, but gee, there's some amazing talent coming through. And I think I'm very confident that we're going to be okay. I think we need to do more, there's no doubt.
Sure.
But just the people that are coming through are very open. And the fact that we have those type of events now, we didn't have that many back 20 years ago, at least that I was aware of. So I think, with the internet we mentioned, I know it's sounding old now, we say, I'll just check the internet, but it's just, the world's a lot smaller now. So I think if we can encourage, particularly the younger generation, and foster them and nurture them. I try to do a lot of mentoring as well for the new engineers coming through.
Awesome.
I was lucky to have some great mentors and experienced old great engineers when I was young. And I think that's important that we keep doing that. And I think we do that pretty well in Australia. I hope we do.
I think we do. I am going to use that Beyond 2000 reference, by the way. What is the take like for mechatronic engineers now? Like, what's the supply and demand like? You've got people there and you can tap in, or is it a limited market? Like, what's the market like? Yeah,
look, it's definitely improved over the last 10 years. More awareness, more graduates coming through. So that's really good. A lot of graduates from overseas as well, as the universities globally bring it on. So that's good. So I think it is at the moment, and there's still people that aren't aware of mechatronics, as we've talked about, and there's also companies that aren't aware of what mechatronics can do. So at the moment, I think it's a pretty good mix of availability. From what I understand, there's a lot of mechatronic graduates that are finding their feet pretty quickly and getting employment, which is great. And being so diverse in the engineering fields, that does help us, I think. So that's one good thing to point out with mechatronics. The one thing that I do find a little bit hard is experience. So things like any engineering degree, it's about finding the experience and the right experience. So I really implore any engineer or anyone in general is don't aim for your ultimate job straight out of university.
Yeah.
It's great if you land it, and I've definitely met some people in my current job who've done a wonderful job out of university and gone great places. But yeah, I personally wouldn't have been able to work for a company in the medtech industry straight out of university. And if I did, I wouldn't be able to offer them what I can now with that experience. So I think if anyone comes out, it's just any experience is good experience.
Yeah.
And I picked up pretty quickly while I was at university. I wasn't the most astute student, I didn't pass all my subjects first time, second time or third time. I have got a degree though, so I eventually passed them all. But I quickly realised that there were people that were graduating at the time that weren't getting jobs. So I was panicking. I thought, well, hang on, if I'm not getting the HDs that they are getting. So I went out and sought experience, and I got a job 2 days a week doing CAD drafting. And literally by the time I graduated, I finished university on a Wednesday, and I had my first job in the welding industry doing robots on a Thursday the next day.
Cool.
And it was just because I had that experience.
Yeah.
And from what I understand at the time, I can't remember the exact numbers, but if 20 people applied for that job, I had the right experience. And it just because, I could do the CAD drafting, and I had robot experience from university. So I think anyone in any engineering field is just get out and get that experience. It doesn't matter where or what, and all those little bit of experience will then, you'll find your path in the world, and end up, where you are and where I am, I think.
It's great advice. I do have a lot of people say, when should I get a job as an undergraduate engineer? And I'm like, well, yesterday. You should have already had one lined up. You need to have navigated your way into a role that you didn't even have to apply for. And any experience is good experience. Even I talk about people working at a cafe or anywhere, just whatever skill sets you can bring, either prior to or at graduation, you've got to be able to tell your story, and it's a skill stack.
Yeah,
And if you've got some engineering stuff in there, like casual, part-time, whatever, get as much as you can, because it'll only leverage your better job opportunity when you graduate.
Yeah, I totally agree. And something like a cafe, I worked in a supermarket for 9 years in high school and university, and it's just that people interaction.
Yeah.
I've got no skills from stacking shelves for 9 years, but it's that, helping customers, talking to people, strangers.
Yeah.
And all those build up until, we're doing multi-million-dollar proposals and business cases. It's all that learnt experience. You could be the best university student in the world, which I certainly wasn't, and have the best marks. If you come out of uni and you can't speak to people, or you can't convince people that your idea is a winner, or your structural design is gonna, you can have all the calculations there, but if you don't get the people across the line, then the university degree doesn't mean much.
I totally agree.
Yeah.
So tell me, Brock, what's next for Brock Dominish? What's next on the horizon? Where are you going? What's your dream, your goal? What does the next part of your career look like?
Oh man, I don't know. So I've got probably 20 years left in me before I retire. So I feel like I'm in that mid career. Let's say midlife crisis, mid-career crisis.
Yeah.
My hair's going grey, and I really don't know. I'm really loving what I'm doing at the moment in the medtech industry. It's exciting. It's very important for everyone in the industry, not just me. So I don't see any plans at this stage. I am passionate about the younger generations coming through. So any mentoring I can do or guidance. I really respect the, lack of a better term, the old fellas that you had growing up and I had. And I learned so much from them, the boilermakers, the managers, the business owners, the old engineers. Most of them grumpy as hell. I'm known to be grumpy, but hopefully I'm not too grumpy. I think it's just trying to foster the new generation coming through, and any opportunity I get, like you ask me to come on, I try to embrace those opportunities. And I have passion about mechatronics. I have a passion about Australian manufacturing. So I really want to be an advocate for that. Hopefully a good one, for the benefit of engineering, the community, and the country. I think it's really important. All politics aside, I think the ability to manufacture in Australia, to produce things, and then export them. If you just do a simple cost analysis, you can see that's beneficial to the economy. And and there's engineers that touch everywhere. Like there's not one thing in this world that an engineer had not touched. I came on the metro here.
Yep.
Amazing. We're in the beautiful building here.
Yeah.
We're sitting on nice chairs that engineers might have programmed a robot to weld in a factory somewhere in the world. And engineering touches every point in our lives, but my passion is Australian manufacturing.
Yeah.
And what that brings to the economy and our culture as well, and just the people. It brings jobs to all walks of life. For the next 20 years, I really want to focus on Australian manufacturing, mechatronics, and see how it goes. I hope that answers the question.
Oh, totally. I mean, it's your answer.
Do you have any recommendations?
Oh, look, of course. Australian manufacturing and retention of talent in Australia is paramount for Australia's future. Most definitely. Advocacy in that role, you need to fit those shoes. Most definitely. That would be my recommendation. Obviously, and I think I touched on it before, but really that whole piece around being future-proof in mechatronics and robotics and that space, that will leverage Australia's future in this technological change that we're going through. So I think you've got a great position to play, and those couple of things, if you can be an advocate for those, speak about those, I think you'll do really well.
Good advice. Thanks, Darren.
Thank you. Thanks so much for coming on the show.
My pleasure.
Yeah, really interesting chat. Really enjoyed that. I'm now thinking about how my robot's going to charge itself. I'm thinking
while it's driving you in the car.
While it's driving me in the car, it's a moment in time that we have to sort of go, okay, well, this is going to happen, and how can we be ready for it?
Yeah, good call out.
Cool.
Thanks,
Thank
Darren.
you. Thanks, Brock.
Pleasure.
Cheers, man.
Thanks so much for listening. I really hope you enjoyed that podcast. Please like and subscribe. It helps us reach so many more aspiring engineering professionals and entrepreneurs. You can find us on LinkedIn, Spotify, and YouTube.